Hello everybody, this is me Khalid Mehraj over again with a new video today. Yesterday we have completed our section of theorems, and now today onwards we shall be discussing parameters, hybrid parameters and impedance parameters, admittance parameters, etc. So let us see what are they. Two-port networks basically. They are studied under two-port networks, and we are still studying DC basics and networks, and under this the heading comes two-port networks. So let us see what are two-port networks. First of all, let us see, we see a resistor like this. How many ports does it have? It is a uniport network basically. The current comes like this, exits like this. It has two terminals. It has only one port if we bind it like this. So there is only one port. And similarly, if we have a inductor, same is the case with that, and same is the case with capacitor as well. They are uniport networks, plus minus. If we give the convention to the current entering and current exiting, they are uniport networks. So what are two-port networks? Now let us see. The examples of uniport networks are resistor, capacitor, inductor, etc. The basic elements that are used in an electrical circuit. So two-port networks, the examples of two-port networks are, for example, we have transmission lines. Two lines enter into an electrical paraphernalia and two lines exit out of it. Similarly, transformer is also a two-port network. Two lines enter it as input and two lines exit it. In the very similar way, that very small transistor used on boards, motherboard, etc., whatever it is, that is also an example of two-port network. Okay, let us see now what are two-port networks and how are they represented in the electrical means. Topic is two-port networks. A two-port network is expressed like this in the form of a diagram. Two-port network. It has two ports. One is input port, another is output port. Let this be input port and this one be output port. Input port, this one be output port. Let us name it 1 dash, port 2 dash. In this way, current enters like this, and on the output port, if we see the convention of the current, it will be expressed like this. So this is the diagrammatic representation of a two-port network. So under those two-port networks, we have to see certain parameters like hybrid parameters, impedance parameters, admittance parameters, ABCD parameters, etc. So what are those parameters? Let us start with impedance parameters today. Okay. Subheading is impedance parameters. First of all, on the rough side, let me give you an introduction. What is impedance? Impedance is written as Z is equal to under root of R square plus XL minus xc whole square. Impedance is the combination of resistance plus capacitance and inductance. So impedance is the combination, is the mixture of all those three things. In DC, we are studying DC networks, basically DC basics. In DC, in direct current, inductor L acts as short circuit. We all know that alternating current is frequency dependent, as it has a rhythm, uprisings and downfalls in the current, in the voltage, and there are phase angles also. But in case of DC, there is no as such thing. There is no frequency sort of thing. So in case of DC, inductor acts as short circuit by giving an infinite impedance, to the circuit. In the similar way, capacitor C acts as open circuit in case of DC, by giving zero impedance to the circuit, to the DC circuit. But here, since we are studying DC basics and networks, so taking it as an aggregate, let us consider there is an impedance which contains a little bit parameters of those also. So impedance parameters, we shall be studying impedance parameters of this two-port network. What is impedance? Impedance is the mixture of resistance, capacitance and inductance. Here we have voltage V1 between point 1 and 1 dash. Here we have voltage V2 between point 2 and 2 dash. The current here is I1, that is driven into the two-port network, and the current here is I2. Okay. So impedance parameters will be as follows. For example, there is some impedance between point 1 and 1 dash, that will be written as, what is impedance written as? Impedance is written as Z as its subscript. 1 and 1 dash, that will be Z11. The impedance between 1 and 2, that will be Z12. The impedance between point 2 and point 1, in the reverse order if you see from here, that will be Z21. And the impedance between 1 dash and 2 dash, similar way, let us see. Okay. Let us see the voltages first. If we write them in the matrix form, it will be like this. V1, V2 is equal to, the impedances will be like this: Z11, Z12, Z21, Z22. I already told those are the impedances between interconvertibly between all those 4 points. Between 1 and 1 dash, that is Z11, 1 and 2, that is Z12, between 2 and 1, that is Z21, between 2 and 2 dash, that is Z22, etc. So what are our currents? I1 and I2. I1 and I2. Each of those impedance parameters, each of those impedances have got their specific names, but naming them at this point of time will be inconvenient. Let us see why. First of all, we shall conclude what each of those impedances mean, and then we shall give them the nomenclature. Okay. So if we expand it, the equations will be like this: V1 is equal to Z11 into I1, Z11 into I1 plus Z12 into I2. Z12 into I2. This is equation first. If we see voltage V2, V2 will be equal to Z2 into I1, sorry, Z21 into I1 plus Z22 into this one, I2. Z22 into I2. Equation number second. Okay. Now let us see, if we have to find this Z11, the value of Z11, what we shall do, we shall somehow make this expression in this equation, we shall make this term equal to 0. How will this become equal to 0? If I2 equal to 0. If I2 equal to 0, what does I2 equal to 0 means? I2 equal to 0 means there is no current flowing into that. There is no current flowing into that. That means open circuit of the port second, output port. Open circuit of the output port. That is open circuit of output port. If I2 equal to 0, then Z12 I2 will be equal to 0. What will be there? V1 is equal to Z11 I1. This implies Z11 will be equal to, since this term is not anymore there, then we will have Z11 equal to V1 upon I1 with I2 equal to 0. What does this mean? This means, we have found Z11. So here Z11 is the impedance of input, right? So here we have taken I2 equal to 0. So this one will be named as input driving. See, Z11, its both subscripts are 1 and 1. Z11 completely denotes the input port, since both of its numerator and denominator, they belong to input. So this belongs to input. So we have written input driving point impedance. So the name of Z11 is input driving point impedance, right? In a similar way, if we take this one, if we take I1 equal to 0, then this expression becomes 0. Which expression is left? This expression is left. Then we will find Z12. If I1 equal to 0, this implies what will happen? Z12 equal to, since this expression is no more there, because we have assumed I1 equal to 0, then this expression becomes 0, then only V1 and Z12 I2 is there. So Z12 will be equal to V1 upon I2. Since this impedance contains resistance, and you already know from Ohm's law. Let's make it very simple. V equal to IR, then R is equal to V upon I. In the similar way, impedance is equal to V upon I. So we have written it like this: Z12 is equal to V1 upon I2. Because impedance is analogous to resistance, as resistance is a part of this impedance. We have made the analogy here. Okay. Z12 is equal to V1 upon I2. We'll write like this: I1 equal to 0. What does I1 equal to 0 mean? I1 equal to 0, I have written this in the very first statement. I will not be writing it open circuit over again in every expression. So remind, I1 equal to 0 means input port is open circuited. Here output port was open circuited. In this case, input port will be open circuited. You may write it down upon your own copy, upon your own notebook. I1 equal to 0, that is input port is open circuited. Input port is open circuited. So we will name it. So here we see one subscript from input, that is 1, and another subscript 2, that is from output. Its numerator is v1, which is from input, and denominator is from output side. I2 is from output side, while voltage v1 is from input side. So this will be a transfer impedance. This is not confined to only one side, input or output, but this contains the parameters from both the sides, that is v1 from input side, I2 from output side. So this will be a transfer impedance. We will write it Z12 as reverse transfer. The name of Z12 will be reverse transfer impedance. Why reverse transfer impedance? Because here the voltage V1 and current I2. If we see from this side, the voltage was this one, if we see from this side, but in our numerator the voltage given is that one. So this impedance will be reverse side impedance, reverse transfer impedance. In a similar way, let us we have done both those things. Let us come to equation second. If to find Z21, we have to make I2 equal to 0. If I2 equal to 0, same as this condition, open circuit of output port. If output port is 0, if I2 equal to 0, this implies what we have to find, Z21. Only this expression will last, this V2 will automatically last, this expression will be wiped out since I2 equal to 0, that is open circuit of output port. Okay. If I2 equal to 0, then what will happen? Z21 will be equal to V2 upon I1. Z21 equal to V2 upon I1, where I2 equal to 0. That is open circuit of output port. You may write it down upon your own notebook. So the name of this one will again be transfer impedance, since one subscript from output, another subscript from one variable from output, another variable from input, voltage from output side, current from the input side. But if we see from here, from the output side, because we always have to deal with the output. What does the output is? What output is given to us by our machine? That denotes its efficiency. How much efficient is that machine? Only then we may buy it from the market. Okay. From this side, if we see in the numerator, it is the voltage that is abruptly upon seeing from this side. So this is forward. This is forward transfer impedance. This is forward transfer impedance. Okay. Which one is forward transfer impedance? Z21. So again, this one has been found. Now remains this one. So if we make I1 equal to 0, if I1 equal to 0, this implies I1 equal to 0, same condition over again. That is input port open circuited. You may write it down there. Input port open circuited. This implies what will happen? Z22 is equal to V2 upon I2. V2 upon I2. In the case I1 equal to 0. This implies what will be the name of Z22? Both the subscripts, both the parameters from the output side. In the likewise, the very first condition is input driving point impedance. This one will be output side, both the parameters from output side. So output driving point impedance. So all the four parameters have been found out, and the names of all the four impedances have been assigned. So let us make it into a simpler diagram now in the form of voltages and currents. if we say, for example, this is point 1 dash, this is point 2 dash, here it is point 1, this becomes the input port. The current from here will be I1, okay. So if we write Z11 I1, here I1 is already there, but we will write Z11 here like this. So Z12, we have to connect Z12 with this, but the current is I1, so we cannot write only Z12 here because the current is I1. We would have to write current I2 along with it. So Z into I, what is Z into I? Analogous to R into I. What is R into I? That is voltage. So we have to make a voltage source here. Z into I is similar to R into I, which becomes the voltage. If R into I becomes a voltage, then Z into I also becomes a voltage. So we would have to make a voltage source here with Z12 I2. This will become a voltage source plus minus Z12 I2. This is only impedance. This becomes the voltage source. Here the voltage is V1 between those 2 points. Positive terminal, negative terminal, input. On the other side, we will make it like this. The same theory will be applicable on the output side also for the equation second. So let me make it directly. It will become like this. The current, to positive, negative. Okay. The current will be I2. The output driving point impedance Z22 will be like this. Z22, voltage is V2. Voltage V2, current I2 on the Z22 required, because here we see Z22 I2. I2 is going into this Z22, so no need to write Z22 along with it. So the another parameter will be like this. It will again become a voltage source, which is that is forward transfer impedance Z21. Z21 will be along with, since current I2, but Z21 requires current I1. Z21 requires current I1, so we'll write a voltage source plus and minus what is that? Z21 I1. This becomes the voltage source. So this is the modified form of this two-port network in the form of impedance parameters. So our impedance parameters are done. Further we shall be doing admittance parameters. What is admittance? Admittance is opposite to the impedance parameters. We shall be doing that in our next lecture. Okay, thank you.